First review for quadratics is quadratics in vertex form. Reminder, vertex form, we have a constant times the quadratic term plus another constant, that's the vertex form, where the numbers h and k actually give you the vertex. In our last chapter, we know that we shift the graph horizontally h units and we shift the graph vertically k units. We shift it in the opposite direction of whatever the number is here, and we shift it the same direction of that number. So one of the skills that's beneficial is to be able to turn a general quadratic function into the vertex form. There are 4 basic steps for the process. The process is called completing the square. The basic steps are put parentheses around your x squared and x terms. You're going to factor out the coefficient in front of the x squared, because you can't complete the square unless there's a 1 in front of the x squared. We're going to add and subtract to make what's inside the parentheses a perfect square. And we are going to write the parentheses as a perfect square, which will turn it into this form. So I'm going to do 3 examples, and I'm going to do those 4 steps using the 3 examples. So starting with the first example, 2x squared plus 8x plus 7. The first step is to put parentheses around the x squared and x terms. Step 2, factor out the coefficient in front of the x squared. I have a 2 in front of the x squared, so I want to factor a 2 out of these 2 terms. And that gives me f of x equals 2 times the quantity of 2x squared divided by 2 is x squared. 8x divided by 2 is 4x. And the 7 stays alone. Step 3. I'm going to add a number in here that's going to turn this into a perfect square. And then I'm going to subtract the corresponding number on the outside. So what number is going to make what's inside here a perfect square? Well, the way you find that out is you take half of this number and then you square it. So half of 4 is 2, and 2 squared is 4. So I'm going to add 4 here. That makes this a perfect square. Well, I need to compensate for adding 4 because I need this line and this line to be mathematically equivalent. But I really didn't add 4. I added 4 times 2, which is 8. So to compensate for that, I need to subtract 8. The last step is to rewrite this as a perfect square, and then I'm going to simplify what's on the right-hand side. So the final part here is f of x equals 2, and the perfect square for here is x plus 2, quantity squared, and then 7 minus 8 is negative 1. So that would be the vertex form for the original quadratic function. Example 2, x squared plus 6x plus 8. Step 1, put parentheses around the first 2 the x squared and the x term. Factor out the leading coefficient. Well, the leading coefficient's already 1, so I don't have to do step 2. Now I'm going to add and subtract numbers in order to make the item inside parentheses a perfect square. In order to find the number that you need to add here, you take the coefficient in front of the x term, you divide it by 2, and then square it. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 here. To compensate for adding 9, I need to subtract 9 times 1, which is 9. And the final form, after I write what's inside the parentheses as a perfect square, is x plus 3, quantity squared, and 8 minus 9 is negative 1. The final example, I've got 3x squared minus 5x plus 4. This one's a little more difficult, but I follow the exact same steps. I put parentheses around the x squared term and the x term. Step 2, factor out the coefficient in front of the x squared term. Well, I need to factor out a 3. 3x squared divided by 3 is x squared. Negative 5x divided by 3 is negative 5/3 x. And leave the 4 alone. Next, I'm going to add or subtract numbers in order to make the middle term a perfect square. The way you find the number that you are going to add in here is you divide this number by 2. Negative 5/3 divided by 2 is negative 5/6. And then I square that number. Negative 5/6 squared is a positive 25/36. So off to the side, I had negative 5/6. I squared it. Negative 5 times negative 5 is a positive 25. 6 times 6 is 36. Now I need to compensate for adding 3 times 25/36, which is 25/12. So I added 25/12, so I must subtract 25/12. My final step is to rewrite the parentheses as a perfect square. So I get 3 times x, and the number here was 5/6 with the minus sign. Quantity squared. 4 is 48/12. 48/12 minus 25/12 is 23/12. And that would be the vertex form of the final example.